Hi, so this session will be on index law 3, which involves brackets and powers, and also the zero power, which is sometimes, called index law 4. Now, if we have something like this, we've got 2 in brackets and the power 3 outside the brackets. Now, really, these brackets don't have to be there. This is the same as saying 2 to the power of 3. But I put the brackets there to emphasize on the index law, where we see brackets. Now, this is just saying 2 to the power of 3 is just saying, well, 2 times 2 times 2, 3 times, which will give us 8. So now if I have something like this, where I have 2a now, brackets to the power of 3, this is simply saying 2a times 2a times 2a 3 times. And so we multiply our numbers as normally. So 2 times 2 is 4, times 2 is 8. And a times a times a, we know when we multiply, we add the powers of the same base. So we end up with a to the power of 3, or a cubed. And I'll write this also before I evaluated it. I would have had 2 to the power of 3, a to the power of 3. So you might start seeing a pattern with what's happening. Let's try another one. So here we have 3ab in brackets, and we're squaring everything. So we're really saying 3ab times 3ab. 3 times 3 is 9, or we get 3 squared. Then we end up with a squared, and we end up with b squared. Now the final answer will be written as 9. So we evaluate the 3 squared, 9a squared, b squared. But if we have a look at this here, we notice that everything in the brackets, 3a and b, ended up having the power of 2. Okay, that's got a 2, that's got a 2, and that's got a 2. So doing it this way, like 3ab times 3ab, which we can, is a longer way of doing it. And sometimes you don't want to do it this way, because imagine instead of 2, imagine I had 20. Would you want to write out 3ab times 3ab 20 times? No, and there is a shortcut. And this index law 3, simply says if you have brackets and a power outside the brackets, all you got to do is get the power outside the brackets and multiply it with every power inside the brackets. So I'm going to use arrows to emphasize that. And now we know that there is an invisible one above the 3 and the a and the b. Okay, and with this index law, we have to multiply the power 2 with every other power in the bracket. So 1 times 2 is 2. 1 times 2 is 2, and 1 times 2 is 2. And that's how we get 3 squared, a squared, and b squared without doing it the long way. So let's try another example. So with this example, we have brackets. Now, another thing I want to point out is that everything inside the brackets is joined by an invisible times. So it's sort of like having one number all squished together. Now, if we had something like this, if we had just say 2 plus x and the power 3, see how that plus is separating the 2 and the x? Well, we cannot apply this index law. Okay, we can't go 3 times that power and 3 times that power. That's a big no-no. So whenever you see addition or subtraction separating variables or numbers and variables, we can't use this index law. And you can see the difference. There is no plus or minus separating any of these variables or the number 2. So I'll just rub this out. Just an important point that I didn't want to forget to tell you. So now this power 3, so according to the index law, if you have a power on the outside of the bracket, so it's a power out here, you multiply it with every other power in the brackets. Now you don't have to do these arrows, but I'm doing them to emphasize that. And of course, this 2 has an invisible power 1 there. Don't forget that. So everything gets a turn to be multiplied with the power 3. So we end up with, well, 1 times 3 is 3. 3 times 3 is 9. Be very careful. Don't write 6 because you added them. 6 times 3 is 18. And 2 times 3 is 6. And now we're almost done. With our numbers, 2 to the power of 3 isn't going to be a very large number. It's just 8. So evaluate your powers when you have numbers. 18 and C6. And that's our final answer. So in your textbook, you will have this index law written without numbers, and I guess it's a rule, and that is if you've got brackets, a power on the outside and a power on the inside, in this case we've got n and m, you multiply m and n together and you still have that same base a. So you might see this in your textbook. Some textbooks might use other variables, but that's fine. So just make sure you understand what's happening here. N times m. Let's do another example. Now, with this example, you notice we've got a 2 out here. That's a whole number 2. And this 2 is not in the brackets. And we notice we've also got a power 2 outside the brackets. So just like with your BODMAS or BIDMAS, brackets comes first and, of course, your powers. So that 2 out here we'll leave out there for now. And we know it's really saying 2 times, there's a divisible times in between the bracket and the 2. So first, let's take care of this power and remove our brackets. So we've got 2 times a 6 and 2 times a 2. We know that index law, that power 2 is multiplied with every power in the brackets. But that 2 is not in the brackets. So we end up with 2 times, we'll just write it like that. And then we've got A, 2 times 2 is 4, so A to the power of 4, and B, 6 times 2 is 12. And we're done. And just to write your final answer, that times here can be invisible. So we end up with, well, 2 times this is just 2, a to the power of 4, and b squared. And that's it. Now with this example, once again you notice we have brackets and a power outside the brackets. So we have to get rid of that power, all those powers. Now there's a plus separating two different terms. So just work with this side and then that side and then add them if you can. So 2 times the invisible power 1, 2 times a 2. And of course 4 times b and 4 times a. So we end up with, well, on this side we have a, 2 times 2 is 4, and then b squared, plus is in the middle. You have a, 1 times 4 is just 4, and 1 times 4 is 4. Now just check and see if we can add these together. Remember, to add these, they have to be exactly the same. We've got a to the power 4, yes, a to the power 4, but unfortunately we have b squared here and b to the power 4 here. These are not like terms, therefore we cannot add them, so we just stop there. Now our next example involves a fraction. And you notice that we've got 2 over x and there's a power 3 outside. And these big brackets obviously indicate that the 2 and the x are both inside these brackets. And this is exactly the same as what we did before. Every power on the inside, this has a power 1, that has a power 1, gets multiplied with the 3. And that's it. Because really we're saying, to do it the long way, we're really saying 2 over x times 2 over x times 2 over x, because 3 times. And this will equal 2 cubed over x times, oh, that's a funny x times x is x cubed, which will then give us 8 over x cubed. Now to avoid the long way, we can use the index law, and that is, well, 1 times 3 is 3 over 1 times 3 is x to the power of 3. And of course, 2 to the power of 3 is 8 over x cubed. And that's it. Now let's try a question that involves, I guess, numbers instead of having variables as your base. Now, a trick is whenever you see division and you notice you've got powers, a good way to work this out is simply, well, writing it like this. 7 to the power of 8 divided by, and I'll write this down here, 7 cubed, whoop, and we're squaring that. And this just makes it a bit more clearer than having the division symbol. So now all we're going to do is first get rid of our brackets and this power 2. And we know that index law is saying 2 times 3. So we end up with 7 to the power of 8 over 2 times 3 is 7 to the power of 6. Now please do not get your calculators and go 7 to the power of 8 is whatever divided by 7 to the power of 6. You'll have very large numbers and it'll take you a while to simplify it. Whereas I want you to use your simplifying skills and, of course, using your knowledge of algebra and index laws. And that is, if we have the same base, for example, instead of 7, if I had x to the power of 8, over x to the power of 6. To simplify this, same base, well, we can take away 6 x's from the bottom, and that's gone. Oops, sorry, nothing there, just a 1. But we must take away 6 from the top, and we end up with x squared on top. So it equals x squared over 1, which is just x squared. But instead of x, what do we have? We have 7. So I'll just rub this out, because sometimes students get confused when they have numbers as their base instead of x's or other variables. So I'm just pointing out that even though it's a number, 7 and 7 is like saying x and x, the same base. So now we do the same thing. Take away 7 sixes from the bottom, just a 1, and take away 7 sixes from the top, we're left with 2 sevens, or 7 squared. So we end up with 7 squared over 1, which is just 7 squared. And of course, we can evaluate it. 7 squared is 49. And that's your final answer. Now, the next index law we're looking at is the zero index law. And this is pretty easy to use. To understand why this works, we'll do an activity in class to see how it works. But basically, anything to the power of 0 is 1. So if I had my rule, a, it's to the power of 0, therefore this equals 1, a whole number 1, and that's it. So you have to remember anything to the power, where the power is 0, it simply equals 1. And the reason for that is, in real life, we always have to start off with something. For example, if we're recording the time it takes for bacteria to reproduce and multiply, which is exponential, their growth is quite fast, we have to start off with at least one bacteria that can then reproduce. It doesn't make sense in real life to start off with nothing. If I say to you, I've got 0 bacteria in my dish, my petri dish, and in 10 hours, I ask you how many bacteria do you think we'll end up with? Well, it'll be 0 because there's nothing. So you got to understand, in real life, when we're measuring something, we have to start off with something, and that's why anything to the power of 0 is 1. Or we know 1 is really saying 100%. So just keep that in mind. And from there, we can either get growth, or we can get decay or decline, and lose percentage or lose value. Okay, let's try these 3 questions. First one, x to the power of 0, that's just equal to 1. We're done. These ones down here, so question 2, you notice we've got something plus something. They're both to the power of 0. So 1 to the power of 0 is just 1. 2 to the power of 0 is just 2, so plus 2. And 1 plus 2 is 3. And we're done. This one down here, you notice the power 0 is outside the bracket. So we've got to get 0 and multiply it with the invisible power 1 and the invisible power 1 here. And of course, 1 times 0 is going to give us 0. And 1 times 0 is going to give us 0. And we can see that A and B, sorry, it's crooked. We can see A and B are both to the power of 0. There's a times in between them. So we're really saying 1 times 1, because A to the power of 0 is 1, B to the power of 0 is 1, and 1 times 1 is 1. So a trick is, if you have brackets and a power 0 on the outside, the whole bracket will just equal 1. So let's look at one more example. So if we have a look at question 4, we notice that we've got 2 out here, which is fine, and a plus 1 over there. But first, our first step is to take care of our power and, of course, get rid of the brackets. And the trick is, we can see what's going to happen. We are going to have 0 times 2 and 0 times 6 and 0 times 1. And the whole thing will be to the power of 0. So the whole thing here is just going to be 1. So we end up with 2 times the 1. We know there's a times there, plus this 1 here. Now, 2 times 1 is just 2, plus 1, and 2 plus 1 is 3. Okay, so all you got to do is simply keep practicing these index laws to get better at them. Thank you.